convert the given words into chemical equation, the given here is magnesium plus chlorine. It will produce magnesium chloride. So simply write the symbol. For magnesium, that's Mg, and for chlorine, that's Cl. Well, you have to remember or take note of this one. Cl is one of the 7 diatomic elements. So these are elements which in nature is diatomic, so meaning they are always in two or always in a pair. So in Br, this means Br2, Cl2, I2, and so on. So Cl is a diatomic atom, so you always put 2 when you see Cl in your chemical formula. So magnesium chloride. So let's check again. These does not show these prefixes, unlike this one. So this is a covalent compound. So these obviously show that it have one carbon and two atoms of oxygen. So we know how many numbers of oxygen is present on this compound. Well, on this one, this is an ionic compound. So ionic compound do not use these prefixes, this di, tri, mono, or tetra. So here we need to check it. We have Mg have two valence electrons, and Cl only now it have 1, 2, 3, 4, 5, 6, 7 valence electrons, so it needs one valence electrons. Mg have two, so it but to be stable, Mg needs to share its two valence electrons. Obviously, one will go to the Cl atom, and to make a stable molecule, we need another Cl atom that will receive the remaining one valence electron from this Mg atom. And so we have the formula is Mg, and we need two Cl atoms. This is the uh, equation for magnesium plus chlorine is equal, it will produce magnesium chloride. Next, we have here sodium carbonate plus phosphoric acid. It will produce sodium phosphate plus carbon dioxide and water. So we know already the chemical equation for carbon dioxide, that's CO2. So we have here carbon, so we don't write mono, but obviously when it is one, it is we don't need to write mono since it's the first element here on this compound. So we have carbon, then dioxide, it means two oxygen, and water is a common name for H2O. Let us complete this equation. So sodium carbonate, sodium is a metal and it is bonded to these ions. So for carbonate, these are polyatomic ions. You can proceed and check your table of elements. You can see this one. So these are the lists of the polyatomic ions and their name. So we have here carbonate. So you look for carbonate and it's over here. So the formula is CO3. So do not mind these charges over here. So you have CO3 carbonate, that's CO3 plus phosphoric acid. For this acid name, we can look at this guide. It will be given on the exam. So phosphoric acid, the formula is H3PO4, and so you write H3PO4. It will produce sodium phosphate. So for sodium, you have Na. Then for phosphate, you again need to look on the table of polyatomic ions. So phosphate. The phosphate we have here, PO4. So this 3 is the charge, but again, do not copy the charge of the ion. And so you have PO4. So sodium phosphate is PO4. Okay, so this is the chemical equation for the sodium carbonate plus phosphoric acid plus sodium phosphate plus carbon dioxide plus water. And again, you can still balance this one, and that will be another task.